Hello guys, welcome back to the VDC space. Today we're gonna be modeling a wind farm using Revit. But as you can see, we are in a Civil 3D workspace. So the reason why we are in a Civil 3D workspace is because we are going to calculate the earthworks for our access routes for the wind farm. Now, the purpose of this tutorial is just for visualization in Revit, but I'm in Civil 3D right now just to use our existing ground and in order for us to model access road for our wind farm and then extract quantities from that. Now, before I get started, I would like to ask you guys to please like, subscribe, and share. If you already subscribed, hit that notification button because I upload BIM modeling tutorials 3 times every week. Now, without further ado, let's start with our project. So, I just opened up the Autodesk template in Civil 3D. So the first thing is I'm just gonna go to insert land XML, and then I'm gonna load in this surface XML, which consists of points. So you can actually get this from my Patreon. That's where I upload my Revit files or Civil 3D files from my tutorials. So make sure you subscribe to my Patreon. So we're gonna insert the XML and then it's gonna generate the points, and then from those points we're gonna create a surface from that, and then we're gonna create an alignment. After we create an alignment, we're going to create a surface profile and then the road profile, and then we're gonna create an assembly, and then we're gonna create a corridor. So we're gonna follow the same logic we do when it comes to road design, except there's one thing. The difference is we're gonna apply the profile of our vertical alignment different way because we are actually designing a gravel road. So it's going to take some time to render. So after you generate your point, you're going to drop down, go to NGL, right click, properties, and then you're just going to change the point level style to elevation only. And then you're going to go to its properties, change the text height to 0.25, and then press OK. And then you're going to change this to also 0.25 just to reduce it and make it more organized, and say apply, and then OK. Now it's going to clean up your points. So after it cleans up your points, you are going to go to surface, right click, create surface, name it the NGL, and then we can change the contour style to 1.5 background and say OK, and then OK. And then you're gonna drop down until you reach point groups. Right click on point groups, you're gonna add it, and then you're gonna add your NGL and say apply, and then OK. Now it's gonna interpolate, and then it's gonna create contours based on those points. So after it creates contours, you're gonna go back to your points, right click, properties, and then you're gonna set these to none, and then you're gonna say apply, and then OK. Now we only have the contours. Perfect. Now it's time to design our gravel road. So the first thing obviously is go to alignment creation tools. You're gonna rename this to access roads. Then after access roads, you're gonna say OK. Go to top left, drop down, and choose tangent with curves. And now you can configure this however you want. So I'm gonna start from this point, and then I'm gonna generate as much curves as I can. So this is what we have. Usually wind farms, they have access long access road uh, that consists of 2 minor curves, and I'm just gonna end it right there and press escape. So this is basically what we have. And I'm just gonna exit that, and then obviously I'm gonna go to profile and say create surface profile, and then I'm gonna load in my NGL and say add, draw in profile view, and then I'm just gonna say next, create profile view, and then I'm gonna click on this screen, and then it's gonna generate your surface profile. Now the basis of designing a gravel road in Civil 3D is you try to limit as much earthworks as much as you can. You try to limit as much earthworks as you can. So you try to limit as much cut and fill as you can, to reduce costs because already you are spending so much going to the borrow pit and also transporting the gravel material to your site. So we're going to go to profile and then drop down. Usually we use profile creation tools, but in this instance, we're going to say create best fit profile. And then we're going to click our profile view. And then on this input data, we're going to drop down and go to surface profile. Make sure your surface is selected. And then I'm just going to reduce this maximum radius and make it 5,000. The curve type parabola, I will say allow above and below. I think it's fine. And then this one is the most important. So profile style, you're gonna change it from existing ground profile to design profile because we are designing this road. And now you can just uncheck these two boxes and say okay. Now it created your gravel road. As you can see, there's limited cut and fill when it comes to the design of your road. So after this, you obviously gonna go to assembly and say create assembly. I'm gonna name it access road, and say okay. And then I'm gonna place my assembly there, select my insertion point, select tool palette, and then I'm gonna go with basic lane transition, and then I'm gonna place it on each side. So it's gonna be placed like that. And when you select your sub-assembly and go to sub-assembly properties, parameters, you have your default width at 3.6 meters, depth at 0.2 meters. The crossfall or slope is 2%. So you're just gonna leave it like that. And after you create your assembly, the next thing is you're gonna create your corridor. So you're gonna say corridor. I'm gonna name it access road, and make sure your alignment is selected, your profile surface profile is selected, your assembly is selected, target surface is your NGL, set the baseline and region parameters, and then you're gonna say okay, and then you can set your targets. So for my targets, I'm just selected. To this one, it's already selected. Then I'm gonna set these ones also, my NGL and my profiles, and also my assemblies, and I think everything is all right. And then I'm gonna say apply rebuild corridor. Okay, and now as you can see, your corridor is created. When you select all of these and then right click, go to object viewer, and then when you navigate, as you can see, this is basically the road you just designed. So after this, obviously, we have to calculate some quantities. And in order for you to do that, so you have to create sample lines first. So after you create your sample line, you're going to select your alignment, and then it's going to create a sample line group and say, okay. And then you're going to drop down this option, and then you're going to say by a range of stations. And then it's going to give you an increment of 20 meters. And then you're going to say, okay, and then press escape. And then it's going to create sample lines at an increment of 20. After you create your sample lines, you're going to drop down your corridors and then go to access roads properties and then go to surfaces. Now you're going to create surface corridors, and then you're going to say create surface corridor, drop down top links, make sure top is selected, and then you're going to add it. Another one for the datum, you're going to say bottom link, drop down datum, and then you're going to add it. Go to boundary, right click, corridor extends as outer boundary. Do the same thing for a second one, and then you want to say apply, rebuild corridor, and say okay. Now it generated corridor surfaces for the top link and also the bottom link, which is the datum level. After that, you're gonna go to analyze, compute material. Make sure your alignment is selected, your sample group is selected, and say okay. You're gonna set your existing ground to NGL, and then usually the datum shows here, so you have to set your datum to datum level. Somehow it's not shown, but it's fine. So you're gonna say okay, and now it's gonna create material. So you're gonna say total volume and say okay, and then you're gonna place it right there, and then it has to generate those volumes right there. So After this, you are actually all done. So we just usually the wind farms consist of small access roads towards your wind turbines, but in this instance, we're just gonna create a long access road when it comes to that. So I'm actually gonna save this file with the right quantities, but I'm just trying to show you the logic and workflow of how to calculate quantities for your basic road design. So after you are done with this, I think it's fine. You can save it. So I've opened up a new project and then I'm gonna insert the land XML again. And then I'm gonna say surface XML open. And then I'm gonna say okay. Now we're just gonna create the basic surface like we did. And we're gonna import it into Revit, and then we're going to create a topo surface, and then we're going to place our wind turbine families and create access roads using subregions using Revit 2023, because that's where subregions are available. So obviously it's going to take some time to render, and after that we're just going to create a surface, and then we're going to take it to Revit. So it generated our points. Let's just clean them up. Actually, there's no need to clean them up. Let's just create a surface just to save some time. Point groups, NGL, apply, and then OK. And then it created our surface. Let's just hide these points. Go to none, and say OK. And now, before we take this to Revit, let's just save it as. So I'm gonna go to documents, the VDC space, and then I'm just gonna save it as WinFarm NGL and say save. And then right after I save this, I'm just gonna type in proxy graphics, and then you're gonna set it to 1 and press enter. And then you're gonna say export, and then you're gonna say export civil 3D drawing. Make sure that this is excluded. This box is unchecked. Include sheets. Make sure you are only transporting only the model, and then you're gonna say export. And now it's gonna export your surface. So after it has exported your DWG, you're gonna go to Revit. So let me close this down. Now I'm in Revit 2023. I open up a construction template and I'm on the site floor plan. And on the site, I'm gonna go to Insert, Link CAD, and then I'm gonna go back to my DWG that I have exported. I'm gonna select it, and then I'm just gonna leave everything as it is and say open. Let's see what happens. Let's just say undo, link cat again. Then I'm gonna select it, set this to meter, and let's see. This is what we have. Now I'm gonna go to the 3D view, and then I'm gonna convert this to a topo surface by going to massing and site topo surface, create from import, select from import instance, and then I'm just gonna uncheck the boundary and say okay. Then it's gonna create a topo surface. You're gonna say finish edit mode, and then you're gonna select this DWG, unpin it, and then you're gonna remove it. Now the basis of topo surface in Revit 2023, what I like about it is they have this sub-region feature, which you can use to model roads just for visualization or other site features. So you can say sub-region, and then I'm just gonna draw my access road. similar to the one that we've generated in Civil 3D, but you guys can configure it however you want. So I'm just going to place it like that. And then I'm going to say pick lines. And then I'm going to set my offset to 5,000. So I'm going to make the total width of my gravel road 5,000 millimeters. And then I'm just going to close it down from this point. Trim and extend. And then I'm going to close it down on also this side. Trim and extend. I'm going to give it a material. So I'm going to name it gravel. Okay. Say finish edit mode. And then when I go to 3D, as you can see, the sub-region conforms to the terrain of our surface. So it's very much a useful feature. But we're not going to stop there. Obviously, I'm going to select it, edit boundary. And then I'm going to, actually before I do that, I'm going to exit, go to insert and say load family. And then I'm going to go to documents and then the VDC space. So I'm gonna load in my wind turbine family, open, go to architecture component, and then I'm gonna place my wind turbines like this. So this will guide me to model my access roads towards my wind turbines. So I'm just gonna place them randomly like that. Perfect. Now I'm gonna select my sub-region and then I'm gonna edit it. And then I'm gonna model my access roads. Each of them will be 5,000 in width. So I'm gonna place them like that. And then another one this side. So it's gonna be 5,000. SL for slice. So I'm gonna slice these points. And then I'm gonna remove them. So I'm gonna do the same thing this side. 5,000. Place them like this. 5,000. SL for slice. And then also for these ones. So you're gonna remove these ones. So we're gonna slice these ones, slice these ones. Then you're gonna remove this. So there's 5 more to go. Let's model these ones quick. 5,000. 5000 SL, slice, 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 slice. Then the last two, 5000, 5000. Then you're gonna place it like that. So as you can see, the level of detail 200, LOD 200, not that much. It's just for visualization, just conceptual. And then you're gonna say finish edit mode, go to the 3D view, select the side, and then you're gonna type in plant, load in plant, and say okay, and set this to realistic. And this is basically how it looks. So this is what you have. So this is very much great for visualization, and the Civil 3D is great for going into too much detail and getting or extracting your quantities, basically rows and earthworks. So yeah, so that's it. Thank you guys for watching, and I hope I can catch you on the next tutorial. Please make sure you like, subscribe, and share, and I will see you on the next one. Peace.